that this is not a magic show, right? Everything that I'm going to do up here is explained by science. And so why don't we have a little bit of fun with our chemistry. Now, whenever I go anywhere to give a presentation, I take Mickey with me, but we walked out of the house this morning without any batteries. But I just happened to have some orange juice with me, and so I'm going to take some orange juice, pour it into this beaker, and as you can see, the clock is running on plain ordinary orange juice. Now, the reason for that is because there are a couple metals in there that produce enough electricity for that clock to run, and hopefully it will keep time while I'm talking. Now, I don't suggest you going home and pouring orange juice into your cell phones or your iPods or whatever, because it's not going to work. Now, people seem to think this is a magic show. Well, really it isn't, even though it seems as though the things that I do are magic. For example, I have this flask here that is plain ordinary pale white, but if I swirl it gently, it turns to a nice pink color. But if I get violent with it, like this, it turns to a nice deep dark blue color. And that is because there are competing reactions going on in that flask. If I allow it to sit for a few minutes, it should go back, and in a few minutes, it happened very quickly. I went back to the pink color, and it will go back to that pale white that I had before. And if I do it again, okay, it's going to turn back to blue. And so it's a reversible reaction, and the chemicals in there are changing pH, and therefore they change color. Now, one of the things that we are all concerned about in the environment is these things. These are Styrofoam Peanuts, and they are made out of polystyrene, and they are very difficult to get rid of, particularly if they were to get out into the streets and the fields, because they don't break apart. However, let's see what I can do with this beaker. I don't think I'm getting very far in filling that beaker, because what's happening is that the styrofoam, the foam is breaking apart, and what I am getting as a result is the plastic polymer, polystyrene, that those Styrofoam Peanuts were made out of. And now, what could happen here is I could take that polystyrene and recycle it to make other polystyrene containers, or I could burn it in an incinerator to produce electricity. But the point is, they don't decompose in the environment. Okay, what I have here are two wash bottles with corks in it. And what I have here is a Tesla coil that produces a spark, same kind of spark that is produced in an automobile engine. Right now, shh, 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 shh. Ready? Whoa, what happened, okay? How was that supposed to happen? Oh, well, lost one kid already, all right. All right, one more time for the lady in the back who's reading in the newspaper and not paying attention to me. All right. All right, whenever I go anywhere, I always like to take a chemistry book with me, because you can always read something and learn something. So occasionally I'll just open my chemistry book up and read a paragraph or two. And as you can see, chemistry is a hot subject. Chemical called ammonia, or ammonium hydroxide, and I'm going to put a few milliliters into this beaker that I have here. And you'll notice that it's colorless. Into this large graduated cylinder, I'm going to put a few milliliters of a mixture of dyes called a universal indicator. And And I'm going to pour my ammonia solution, which is colorless, into this cylinder. Now, it is quite obvious that it turned a nice purple color. That's okay, all right. Now, the reason for that is that at this pH, or that acid level, ammonia is basic. And so it's going to give it that color. But now, what I'm going to do is I'm going to add something that perhaps you are familiar with, and it's called dry ice, which is solid carbon dioxide. Solid carbon dioxide is going to react with the water to form an acid. It's going to neutralize the base and hopefully make this solution more acidic. And watch what happens when I put the dry ice into the cylinder. Watch the vapors come over the top down to the floor, and watch the color change, okay? We're on. I'm going to light a burner and do some experiments for you with a burner. Now, I have 3 metals here that perhaps you are familiar with. This is an iron nail, and if I put it into the hot flame, after a few minutes or so, somebody answer the phone. All right, as you can see, it's going to turn red hot. And that's the condition of iron at that temperature, about 1100, 1200 degrees Celsius. But if I cool that down quickly or slowly, it comes back to the iron nail. Scientists call that a physical change. I'm sorry, okay, I can't make it any better. All right, this is a piece of aluminum. And aluminum is found in step ladders, it's found in automobile engines, it's also found in beverage cans and pots and pans. Now, here's the point. If you happen to have an electric stove or a gas stove at home and you have an aluminum pot or pan, there's always the tendency to melt the aluminum if there is no liquid in there. But as you can see, it turned red and it also melted. And if I cool that down quickly or slowly, all right, it comes back, but in a different shape. Scientists call that a physical change also. Now, this last metal, now you don't have to hold your ears, it's not going to be loud, okay? But you're going to have to watch your eyes. All right, this piece of metal is magnesium. And magnesium is a very strong, lightweight metal. And I'm going to put it into the flame. Now, when I put it into the flame, I don't want you to look at the flame. I want you to look at my left hand up here. And so out of the corner of your eye, okay, up here, left hand, okay, but out of the corner of your eye, you're going to see a very, very bright flame. And that is because the magnesium is combining with the oxygen in the air and forming a new compound. And scientists call this a chemical change. Now, this is called magnesium oxide. Now, I have some cans here, and one of the things that we want to do with our aluminum cans is that we want to recycle them. And before you take them to the recycling center, they usually want to have them crushed so they take up less space. Well, what I'm going to do is that I'm going to take a little bit of water in the bottom of this can, and I'm going to heat it up to boiling. And water vapor takes up a lot more space than liquid water does. And I'm going to fill this can with steam, hopefully. Oh, come on. steam, please. Here it goes. All right, see the steam coming out? All right, so now this can is full of steam or water vapor. If I cool it down quickly, watch what happens. I'm going to take a little bit of dishwashing liquid and swirl it around a little bit, make a nice homogeneous mixture. I'm going to take a few grams of a chemical called potassium iodide and put it into that solution. See what happens. Now, this last balloon. In this last balloon, I put the oxygen right in with the hydrogen, and so it doesn't have to seek it out. See how different this one is from the previous one. Okay, are we ready?